So this is where we had stopped our lecture last time, and here we could find that how the data files are organized in the memory map of Allen Bradley PLC 5 controller. Now let us see about each and every of the aspects of these sectors in the data files. We will definitely drop some of them. Maybe we will be definitely drop this discussion and control files, and we will be concentrating more on the files which are going to be required during our course of discussions in the mathematical section. Now you can see that the PLC 5 and SLC 500, they store all data in global data tables and are based on 16-bit operations. Global data table means that they are having address, and with the help of that address, whatever data is there in that particular address, that can be accessed during course of any program. And the registers, the data registers, whatever they are of 16 bits, and they are capable of operation with 16 bits at a time. Now you can see these whatever data, since it is global data table, that can be accessed with the help of address, and these data can be accessed by specifying the address of the data. Now definitely whenever we talk of address, we need to be very considerate that what is the format of the address. Okay, so the format is not very unknown to you, actually, but still I will just discuss on them because of the purpose of recapitulation of your ideas. You can see the output data file or the input data file. They are the potential locations for input modules, or if you need to send some information to the output module, that is very much required. And this input module and output module are mounted to the I/O chassis of the PLC, and definitely they are connected to the input data file and output data file through internal connections. You can see that for example, we have taken this particular address as the output image of the table file, output image table file rather, and what this particular address they do specify. You can find that if we say that this is O means for output, then 0 1 2 / 15. So 0 1 2 3 digits are there. In this particular thing, this 1 stands for rack, then this 2 stands for IO group 2, and 15 is the bit number, that is 15. Okay, accordingly the input is also there. We can see the thing may be more clear through this particular diagram. You can see over there, this is the main PLC, and these are the racks that are connected to the PLC. This I or O that specifies whether it is an input designation or output designation. That means input file or output file we are talking about. Definitely we have a separator before we specify the address. Then there is the slot number at the beginning, then there is a bit designator, and then there is the bit number. Okay, so this is how the address is written in case of PLC 5 or SLC family of PLCs for Allen Bradley. Now let us see that what are the various sections in this data file unit. Now you see that let us talk first about the status data file. It contains information about the processor status. Okay, the example is like this to show how the address actually work. The address here given what is S then colon 015. This addresses word 15 of the status file. Now you need to understand that here we have already said that all the data, they are based on 16-bit operation. So you can find that here the word is there. That means this particular address that contains a 16-bit data. Okay, so here we are specifying word 15 of the status file, and this is a more elaborated address where we have talked about a particular bit in word 27 of the status file. So here we were talking of the entire status file, but here we are talking about that particular bit, that is bit number 9 in word 27 of the status file. Next comes the bit data file. The bit data file actually stores the bit status, as the name suggests. It frequently serves for storage when using internal outputs, sequencers, bit shift informations, and logical instructions. You have, I think, you have already gone through that particular topic called internal relay operations. Suppose you have got two particular output conditions that are to be compared, and finally the result has to be reflected in an output. Now if the two output conditions that has to be compared, and these input conditions, the input conditions that generate these two outputs is something like this. Output 1 is dependent on 16 different inputs, where output 2 is dependent on 8 different inputs. Okay, so there are in all 24 inputs. Group A contains 16 inputs and group B contains 8 inputs. The 16 inputs, they generate this output A, and these 8 inputs, they generate output B. Now when A and B is going to be compared, then the final output will be generated, and which will be ultimately reflected on the output image file. And definitely whatever is reflected on the output image file, that will be uh, transmitted to the IO chassis, that is the output chassis. You will be getting the data. Now you see that whenever such condition is there, then we actually use that internal relay. Now internal relays, when they operate, where should they put their information? So for that purpose, this bit data file is there. Here the address is given, address B3400. This particular address, this addresses is the word 400 of the bit file. Now remember, one very important point I have written over here, that input, output and status data files are the only files that do not require the file designator, because they can only be one input data, one output data and one status data file. Okay, this concept is very important. You can see over here that we have written this B3400. Okay, however it is written here S015. Here S1 or S2, it is not written like that. Okay, this is because the input, output and status data files, they are the only files that do not require the file number designator. For everyone who are not input, output or status data file, you need this file designator. This one important thing you need to keep in your mind throughout. Next comes definitely the timer. Okay, the timer stores timer status and timer data. You need to remember that timer element that consists of three words actually. Number one, it should be the control word, then there is the preset word, and third is the accumulated word. Now this is quite I should say acceptable, because the control word actually shows you the particular designation of the timer. Here it is timer 4.0. If the control word is 4.1, that will denote a different timer. So the first word, this is a 3-word address. So here, the 3-word entire data file, where the first word is the control word, which shows which timer it is that. Next comes the address of the preset word. You can see it is T4.0, then TRE, and finally it is the accumulated word, that is T4.0.acc. Now what does this accumulated word means and the preset word means? Now you see, whenever you are working with a timer, you give a preset time over there, isn't it? So when you give the preset time, actually that preset time has to be stored somewhere. So that is going to be stored at T4.0 PRE, and this whatever the timer counts, they are kept in the accumulator. So that will be kept in the T4:0 accumulator, dot accumulator. So these concepts are very important, you know. Therefore you need three control words, one for the control word, then for the preset word, and finally it is there for the accumulated word. So you see that whenever we are working with these timers, we barely think that where actually whenever there is a window is there in this particular Allen Bradley format. I will show you. Yes, here you can find that there is the timer T4.0. The time base is given. 1 is the time base, 1.0 is the time base, this is the preset. So here you can just put the data. Now you can see this is the preset thing. Okay, so this is what you need to fill up. This you fill actually. So whenever we are filling, we barely think that we are filling it somewhere, but where should it go? Because this is one data that you are feeding the timer. that you need to count up to 20. Okay, so this preset value, it will be stored somewhere in the memory organization. So that will be stored in the T4.0.pre location. Now comes this accumulator. So when the timer starts counting in the accumulator, each of the count get accumulated. So this, when the timer starts the timing, how will it happen? The accumulator will be incremented by 1, 2, 3 like this, because this is a T on timer. Okay, it will be accumulated 1, 2, 3, 4 like this. Fine. So when the accumulator is getting incremented, then definitely some data is getting incremented, isn't it? It is incremented bit by bit. So where does this particular data will be stored? Because this is also a sort of data. This accumulator is counting. Where will be the count be preserved? You need to do something now, because whenever you are calculating something in your mind, it is 47, maybe 47 by 76. So what you are doing, 47 plus 76, you can easily feel that you are putting these two data somewhere in your brain. Otherwise, without putting it inside the brain, how can you think of that, isn't it? Next, you have to do the 7 plus 6 is equal to 13. 13 means 3 will be somewhere. Okay, now this one is carry generated, that has to be kept at some location in your mind. So whenever we put some data from the external world to it, external world to this preset value, so that will be located somewhere. The timer starts counting, so whatever that count, that will be put in the accumulator, and the contents of the accumulator will be placed somewhere. So therefore these things are there, this accumulator is there. Now definitely there are three output bits for any timer. We have seen in our earlier unit that one is the enable bit. This is the enable bit address. This is the control word T40EN. Then the timer timing bit address is T40TT, and the done bit address is T40DN. Because this enable, TT or DN, they are all some or other way they are connected to the output file register. So whatever data is going to the output file register, that data has to be again stored at some location. So these are the locations. So now you can understand very easily that whenever we are talking of timers, whenever you are talking of timers, you can see that there is a large number of I should say area that has been designated for this timer. This is the reason.